So recently, NVIDIA launched something they called NVIDIA Object-Oriented Agents. And they really wanted to create, in my opinion, a different abstraction when it comes to building AI agents. So we have become so used to having a system prompt, a knowledge graph, or some kind of workflow that directs the agent. And we have tools and memory. And with NVIDIA Object-Oriented Agents, they really want to replace the system prompts with classes and methods, doc strings. They want to replace tools with methods, and workflows is really replaced by code. And I really wanted to experiment with this new way of building AI agents, the NVIDIA Object-Oriented Agent library. And I wanted to combine it with NIM. So NIM is really a great way to get access to open source models and experiment with open source models. And the best way for me to get my head around this new way of building agents making use of Python was to create this user interface where you can actually generate NVIDIA object-oriented agents in this interface called ClassAct. So you will see that the whole idea is to get started, create your class and your methods, and then copy that source from here and paste it into your build or code environment. So this is not an end-to-end workflow builder or a new IDE. It's a way of creating a agent class and also the methods and then testing it. So briefly, you will see I've got different agents here. I've got two existing templates. These are agents I created. You can delete them. If you go to run, I can choose which agent I want to run, what method in that agent I want to run, and what model I want to make use of. So I've got some models here. I normally default to the Nemotron 3.5 Lightning model. And you can see the reply here from the model. You can see the JSON and the live trace from that inference. So I can run inference from here to my NIM instance. I can also watch. So I've got some of the logs here. And most excitingly, I can build an agent here, right? So I've got my basic agent defined here. I can define my method. So I've got two kinds of methods, an agentic one or a Python one. So the Python method is more deterministic. The agentic is non-deterministic reasoning based. I can have different strategies, so I can predict, or I can have more of a code approach. I've got my arguments here, and I can give a description of my agent here. So from here, I can go to...
So to create a new agent, I go to inspect, I can say new agent, and my class name is WeatherBot. I click on the plus, and I can say check weather. I've got my kind of method, agentic or Python code-based. My strategy is it predict or code act. Check the current weather. Okay, so from here I can click on the plus sign and I've got a method here. Check humidity or check weather. I generate the source here, so this I can copy and paste into my Python code, but maybe I want to just see the latency and the response times, the tokens. So I click on agent, I select WeatherBot, my two methods show up. Check humidity, I again go for the Lightning model and I say, what is the humidity currently in Cape Town? And I run my agent, I get a response back from the model, and I can see which model was queried and the value returned. If I click on watch, then I can see more detail in terms of the output, the input.
You can see the whole idea is to get a basic nucleus of your agent tested, to see the interaction of your agent with your open source model. And from there, you can copy it and paste it into your Python code.